Hello everyone, today we are back with a new CTF solving video on Pwnable.kr, and for today we will try to solve the passcode challenge. So to begin with, I've already opened the connection here in my terminal, and we will start by analyzing the files. So we have a flag file which of course we can't yet discover, a passcode binary, and the binary is C code. If we go back here, we have some hints for this. So mommy told me to make a postcode based login system. My first trials implementation compiled without any error. Well, there were some compiler warnings, but who cares about that? Okay, so firstly, let's try to run the binary and see what happens. So it goes into the main function, it calls the welcome function where it makes a buffer of 100 characters, and it reads into that buffer exactly 100 characters. So this %100s tells the scanf function that no matter how many characters are inputted, it will only read 100. So this is like a buffer overflow protection. So only 100 characters will be read. Let's input something here like that, and then what happens, it goes back into the main function, calls the login, it declares two integers, passcode 1, passcode 2, and we are right here where it asks for input. It scans into the passcode 1 integer and reads it as a decimal. Okay, so let's give it some input. Okay, and then enter passcode 2, and it scans in passcode 2 also as decimal. So if we have something like that, it tells us segmentation fault core dump. So let's see what is happening further. It takes passcode 1 and passcode 2 and compares them to 1, 2, 3, 4, 5, 6 and this number. And then it calls, okay, it cuts the flag, else it prints login failed and exits. But this is pretty strange because we get neither of those. We got a segmentation fault. So let's try to run it again, and let's input those 1 2 3 4 5 6 and 1 2 3 1 3 3 7 1 3 3 7, and we got a segmentation fault again. Let's look at the binary maybe, or first let's take the code and try to compile it, because there may be a hint in here. We'll do this like that and take this code, create a temporary directory, go into it, and I'll just create a file here, and I'll compile it so we can basically see what are the compiler warnings that they're being said in the description of the challenge. Let's compile this and let's see. Okay, so we have a warning here: format decimal expects argument of type integer pointer, but argument 2 has type of integer. Okay, and the passcode second scanf is the basically the same thing here. Okay, this doesn't matter right now, but what really matters is that scanf expects a pointer to int, so a memory address where an integer is stored, but we gave it an integer because scanf here takes an integer and not a memory address. And basically, let's go back and let's go into the manual of scanf to see exactly how this works. So Function scans input according to format as described below. The format contains specification. The results from such conversion are stored in the locations pointed to by the pointer arguments that follow format. So the results from such conversions are stored in the locations pointed to by the pointer arguments that follow format. So, and here, if the number of pointer arguments exceed the number of points, yeah. Okay. So what is important is basically here. It says are stored in the locations pointed to by the pointer arguments that follow format. So basically what scanf does is it takes a memory address which is in conformance with the format specifier. So if we say %d, it means it's a decimal. So int works or maybe float works and so on. So scanf takes a memory address, it goes to that memory address, and at that memory address it basically puts what we input. And right now, because we don't give it a memory address, we give it a value. It takes that value and treats it as a memory address, but it's normal that what we gave it as input, so for example 1 2 3 4 5 6 isn't a memory address. So when it tries to go there, and when it tries to read from there, it realizes that it's nothing, and we get a segmentation fault basically. So this is our vulnerability right here. Let's see again the C code to make a better idea, and let's run the passcode. So basically we're here entering our name and then passcode 1. So we have two initializations, passcode 1 and passcode 2, which we see that they are declared but they are not initialized. So inside them there will be some garbage values. That being said, when we enter passcode 1, so for example 1 2 3, it gets here to scanf and it takes 1 2 3. Instead of giving it the address of passcode 1, we basically give the value that it is in passcode 1. But right now in passcode 1 there may be some garbage values because passcode 1 isn't initialized. And what it basically does, takes that garbage value and treats it as a memory address, tries to go at that memory address, and is trying to put 1 2 3 there. And when we do the same for passcode 2, we are getting a segmentation fault, yeah, because those memory address that we treat here and here don't exist. So to go further, let's dump the code of the binary so we can see better what's happening here. Okay, I'm gonna find the login function because that's what we want. So here is the beginning of the function, calling a flash. Here is the first scan, here is the second scan. So if we can see, okay, if we go a little bit down, we can see that there's the first comparison here. This is the second comparison and this is the first comparison. When what happens is it compares this number in hexa, which I think this will probably be 1 2 3 4 5 6. Let me just, okay, so if we take it in hexadecimal here, yeah, it's 1 2 3 4 5 6. And if we go to the second compare, here it compares this with this is 3 1 whatever. Didn't copy it good, I think, or no, that's good. So this is the second number in hexa. That basically means that here, lost the comparison here, it compares 1 2 3 4 5 6 with what is at EBP in the EBP register -10 on the stack, and in the second compare it compares this with what is that -0 XC in EBP, which is passcode 2. So for now we can make a notepad right here, and let's just trace this. So we know that passcode 1 is at EBP -10, and passcode 2 is at EBP minus what? Minus C. So minus 0xC, and let's see here minus 0x10. Okay, so let's maybe we can go a little bit with the debugger, but so if we go back, let's see, passcode C, we have a buffer of 100. So let's see what happens when we try to fill the buffer. Write an Python script that will generate 100 days. That's good. I'm gonna copy that from here, and let's go with the GDB right into passcode. Okay, that's good. Let's run it first to see what is happening. So starting the program, entering your name, gonna copy this, enter passcode 1, doesn't matter, and it crashes directly. Okay, so we have an input of 100, and after the first passcode it crashes. What happens? We have here the trace, we have here the password. Okay, this is the stack with the yellow is the stack, and that's interesting. So in ECX there's some maze, and EDX we can see it's filled with A, so the last 4 bytes. So just to make sure that this is the case, I'm gonna run this again, delete the last 4 bytes and put B. So I want to see that now we have B in there. Yeah, that's right. So EDX, the register EDX is filled with the last 4 bytes of the welcome buffer, and this basically happens because in the memory the stack reuses throughout the functions that are called, and defining garbage values which are not initialized can have some values that are meant to be for other functions, but because the stack reuses, we can basically access those things, which represents vulnerability. But it's important to see where exactly on the stack this is. So EDX, yeah, the register is now VVV, but where exactly on the stack is this? Because, for example, if it would be maybe at EBP -C or at EBP -10, it would mean that we could overwrite the values in those. And if we could put, instead of a garbage value, if we could put maybe some memory address, then some memory address will go into our C program, and then we can overwrite something at a memory address that we want. So for now, let's put a breakpoint in login function and see that I have 2 breakpoints. Okay, so let's go like that, and we hit the breakpoint. Want to see what's really here? Nothing right now. And if we go with next instruction, okay, so ESP gets those, and if I do something like ESP, so I want to see the stack. Yeah, so we can see that reading the stack, we have here the B characters, and if I maybe 20x EBP minus 16, let's say, exactly here we have the b's, so that means it's exactly, let's step one more instruction just to be sure. Next instruction, that's good. And let's read from there, of course, EBP minus 10. Can't see anything at EBP minus 10, but yeah, because it's taking specifically from EBP minus 10. But if I do minus 16, you can see that here exactly 4 bytes. So that means, yeah, that basically means if I continue this, enter passcode 1, it if I hit continue here, because here is exactly EBP minus 10. So here at EBP minus 10, when we're reading from the memory directly in the GDB, here is EBP minus 10, and now at EBP minus 10 there is this, so 61, 61, 61, 61, and when if I continue here and then I input something in there, the scanf will treat this as a memory address, which basically doesn't exist, and tries to put the value that I input in that memory address. So now that we know that, we can overwrite some memory addresses. Let's look for this. So passcode.c. I want to see what system functions are called, because then I can maybe go into the global offset table and look for some memory addresses I can override. So have the exit here. And in fact, what is really interesting is that after the first scan, f flash is called, but the second time it isn't called. So maybe it's something with this f flash. Let's see if we read the elf data minus say passcode. We see this right here, and if we go here, we see that we have exit right here at this memory address. So let's also note this exit in say rel-plt exit is at the memory address what 0804 C028, and f flash is at what address, at 0804 C014. And if we could take that address and give it as the last 4 bytes in the welcome buffer, then I think that that would be the value of passcode 1. And let's see if that is right. So if we go again into GDB passcode and let's hit, now we can basically run. So got the A's again. No, that's wrong. I don't think I need to write another exploit, but I won't do that right now. So we can exit from here. So basically, if we have that, let's look at the code again one more time. If we can give this or this as the last 4 bytes here in the welcome buffer, that means the value of the passcode 1 will be exactly this memory address. And if this is the value, that means scanf will scanf called with the value of passcode 1 will treat that as a memory zone, but the value of passcode 1 will be then really a memory zone. So what it will do, it will go at that memory zone, which is located in PLT procedure linkage table, and it will override there the address of what or whatever value we want, because basically this is what procedure linkage table does. It puts at some memory address in the global offset table some functions and calls them. So basically when we go to some memory address in the global offset table, we then call some functions. But if we can override the functions in the functions that are in the global offset table at some memory address, then we can make the program call what we want. So if we could override the value of fflash, when we call fflash, it will go into global offset table, and instead of calling the system call of fflash, it will call whatever we want. But for that, we need to give it a memory address. And to give it a memory address, we will simply think we can directly jump into here inside of the if. So let's see a little bit again. Object dump minus the passcode. We wait for it to disassemble, and if we go up here, I want to see exactly. Okay, so scan F here. I want to see the compare instructions here. So okay, jump not equal. So here must be the, so at least should be the print F. And basically if we take that address, so address to jump to, and let's say here address is to overwrite, are those, and address to jump to is this. So we can maybe start to craft the exploit. Let's see. I'm gonna clear this, and let's try to do something like -c print, and now let's do something like b or multiplied by 96, in fact, plus what? We can have something like so we need to take this memory address, but we need to write it as little endian. That means it's 14 x c0 x04 x08, and then so this will be the value of passcode 1. When we call scanf, it will jump to this memory address, which is the address of fflash in the global offset table, and then what we want to do is to give it the value. So the value will basically be this, only that scanf expects it in decimal. So here, and here is the decimal value that we need to give to it. And this, go back, and I can see here 134, 517, and 391. And let's call passcode with it. And it says login failed, but there's something wrong with the exploit. A second, concat. Okay, those are bytes, and those are treated as a string. So don't really know why those are treated as strings. Let's see again. Okay, because those won't be bytes. So we can concat bytes. Let's see what happens if we maybe cut this here and this here, and it says login failed. but interesting right now that we aren't getting segmentation fault. So why are we not getting a segmentation fault right now? What is happening? Maybe. So this was interesting right here. It says we can't concat string and bytes. But why? Because the bytes here. What if I go here and let's say something like how to write row bytes in Python? Bytes. Oh no. Yeah, this is better. Okay. So this is the syntax. Let's watch here. So it would be something like that. It would be -c and import sys and then sys dot standard out dot buffer dot write and then it would be what a plus bytes of what? Bytes of maybe our address in little endian. No, it's 0x 0804C014 our address plus what? Plus our decimal value. So our decimal value is basically 134 517391. Let's see what happens now. So it's the same problem right here. Can't bytes must be in range 0 256 because maybe this is the syntax wrong here. See bytes right here can only concatenate to bytes. Yeah, so that's clearly wrong. Let me check a little bit and I'll come. Okay, so I'm back. Yeah, this clearly doesn't work, but we're gonna try. I looked a little bit over the syntax, so let's do like that. So of course again import sys is good. Sys dot standard out dot buffer dot write and what? So we're gonna send bytes instead of a's, which is basically the same thing, and we'll also send again 96 bytes and then plus, and then we're gonna send bytes our memory address, which will be x14xc0 x04 and x08, and then what is very important, we'll print, so it will send a new line, so basically enter, and then what will we do is basically we will send the decimal value, so 134517391, and then passcode, and then we will call passcode, and it still didn't work. Why it didn't work now? So 96 plus b x14 x c0 x04 x08 print 13451 7391. So maybe it wants something also for the second passcode, no? Not really. But now unterminated literal string. Okay, here is unterminated literal string. Yeah. So still didn't work. Maybe it's the syntax of how it's written here. So if I try to write it in Notepad like that, import sys and then sys standard out that buffer that write, and then here bytes of what 0x01 or 96 plus bytes of x14 xc0 x04 x08, and then write print like that, and then print like this 1 3 4 1 3 4 5 1 7 391, and then print again 1, and then close those and run passcode. Let's see if it does something like this, because maybe it doesn't read right with the syntax that I wrote on one line. Yeah. Oh, good. We got a flag here. So yeah, the syntax here was the problem. I don't know. Really, maybe it doesn't see those semicolons, but who knows? So yeah, basically we have pawned this and managed to get the flag. What happened once we have overwritten the f-flash address? So here we have overwritten the f-flash address. On the next line, when f-flash is called, we are directly jumping in here to login OK, and the system gives us permissions, and it calls the flag. It casts the flag. So thank you everyone for watching, and see you next time.